All right.
All right. My name is Matt Reisinger. If you know me, I'm a builder in Austin, Texas, and my only cool claim to fame is I'm the founder of the Build Show, and I've got with me the famous Eric Ani.
I'm Eric Ani. I'm a master plumber from Minnesota.
I am super excited about today's program because, well, for a couple of reasons. Number one, we are actually live on YouTube right now as well. So if you guys wave, you can watch this later and see yourself on the YouTubes. We're doing a live recording now. This is our Friday video this week. We were going to give our YouTube friends watching this right now a bit of an insight on what they missed today at Build Show Live here in Dallas. Also, if you're watching this, whether you're in the audience or whether you're on the YouTubes, make sure you sign up for Build Show Live 2026. We already have the dates. It's like the second week in September in San Antonio, Texas. So we're making our Texas tour. Unfortunately, the Trade Convention Center in Austin got torn down right after we were done. There's a few jokes been made about how builders kind of ruined it and then it couldn't be cleaned properly, so they had to literally tear it down after we left. I don't think there's any truth to that. Certainly Matt and I could have cleaned it up, but long story short, we're taking a little bit of a tour of Texas. Plus, it allows us to get some people that maybe didn't have the budget to fly in, but were willing to drive into Dallas. So I really appreciate you guys. Eric and I are going to do a presentation today that's really a very shortened version of something we've done for video that's going to be coming out really soon. In fact, I just talked to the editor today, and it's on his edit desk. Austin's editing this one for us.
We don't have a clicker. We don't have
any slides.
Okay,
we're good.
No slides, guys.
No slides. You're good. But Eric, give these guys like your overview of the perfect plumbing plan. What are we talking about, Eric?
Well, the perfect plumbing plan, like you said, is a series we just shot for the Build Show Network, and it's becoming soon. We took a lot of great insight and a lot of what a friend of ours, industry great, honestly, when it comes to plumbing. His name is Gary Klein, engineer. He lives in California.
Yeah, he's from California.
Gary was at the inaugural.
He was. He couldn't make it this time, unfortunately.
Yeah. So Gary's turned into what his life work is trying to educate builders, code bodies, manufacturers about water usage and how we can do better in the design of our plumbing systems to use less water and not affect the performance or our comfort or our interaction with our plumbing in our homes in any negative way.
Yeah, and in fact, really what we're trying to solve here is that issue of how do I get hot water to my tap the quickest? For any of you that were staying at the Omni Hotel, when you turned your shower on at the Omni this morning or last night, whenever you showered, how long did it take before that water got hot at the Omni? Anybody raise their hand? Did it take over 2 minutes for the water to get hot at the Omni? No, nobody. How about, did it take a minute for the water to get hot at the Omni? Nobody. Did it take, like, at my shower, like 5 seconds before that water was hot? Most of you guys?
I'd say less.
Maybe less. Yeah. I turned that shower on, and literally, as soon as I put my hand up, I was like, oh, wow, okay, turn it back down to cold. It was seconds before I was hot here.
Yeah, so you might think we're going to just talk about hot water recirculation, because that's how we do that, right? With a plumbing system, we can get hot water to your fixture faster, how we install the plumbing, and also how we can add a couple of simple components to the system that are reliable and make our interaction with it a lot easier. Get that hot water there faster. This isn't really necessarily all about hot water recirc, although we'll talk about it.
We will talk about it a little bit, but if I can rewind time, I did a remodel on my personal house about 15 years ago. This is a 1970s build. We're in Texas, a lot of slab on grade construction in Texas, where we typically either run our water lines under the slab, which is frankly not a great place, because if you have a leak, you might not know about it for a long, long time. Or sometimes we'll run our water pipes through a really hot attic, which is also a really dumb place to put pipes. But at that house, I had a tankless water heater and an instantaneous water heater. My wife's like, why is the water not instantaneous? I'm turning it on, it's not instantaneous. It had about 75 piped feet of 3/4 line from my water heater on this side of the house. It was a Renai. It was a great water heater. 75 feet of 3/4 line to get to the other side of the house when my wife turns the shower on. She would literally turn on the water, read a book, put the kids to bed, and then come back to a hot shower. It was, I'm exaggerating, but I bet it was probably 2 minutes to get hot water at that house. If the line was cold, to go from where my water heater was to where the shower head was. I think that this demo that Eric has for you is going to help with that. Eric, should we get some volunteers to help us?
Yeah, I need 3 people.
Who's not shy? Come on,
Come on up here. Just
Come on,
3
George,
people.
get up here.
You can walk up here. You don't need a mic up or anything.
George, you need a friend.
There you go. There are stairs.
We need one more friend.
I think when you leave, take the stairs so we don't get yelled at. Okay. I'm gonna give each of you a piece of pipe to hold, and then Matt and I know what's going on. But the funny thing is that you don't. And in the process, we're gonna.
You're not supposed to tell them the punchline ahead of time.
Oh yeah. Okay.
Darn. I'll hold one end of that. You hold the other.
Yep. I'm gonna take the. I'm gonna take this one, and you can hold that one yourself.
Okay. All right.
All right. Anybody that attended the Build Show Live last year and sat in on Gary Klein's classroom education, you might be familiar with this, but
actually, we should go on the backside of you. That way we get the pipes in order.
Okay. And so we've got 3/4 inch PEX. This is all PEX product, right? You're familiar with it, and it's just easy to travel with, so that's why we're using it. Also typical of what's being installed in your homes. We got 3/4 inch PEX. How long do you think that is there?
What do you think that is, George?
4 feet? It's close. It's just about 6 feet.
Okay.
Now this is 1/2 inch pipe, right? So 3/4 and 1/2, the 2 most common sizes that we see installed in our homes. And this was roughly 12 feet of pipe.
Okay, so we got 6 feet, we got 12 feet. And what size pipe is this little guy?
So that's 3/8 tubing, right? And that is how long was that?
I think
16
around
feet?
16 feet.
Little over 16
These are
feet.
8-foot sheets of Huber Advantech. Let's see how many sheets of Huber Advantech it is. It's a little more than that, actually.
We'll call it
'cause
18
that's
feet.
16. It's about 18.
Yeah, 18
Did you
feet.
measure at 18.6? Was that? Are you have a calibrated eyeball? I'm impressed, dude. Way to go.
All right, so all of these, we're doing this for a reason, and it's to really put a finer point on what Gary's research has done and what the Perfect Plumbing Plan series is all about, is getting that water to the fixture, the hot water there faster without wasting any water. Can anybody give me a guess of what the correlation is between the 3 sizes of pipe that we have up here? Same water volume. Yeah, you guys nailed it. Gosh.
How much do you think this is? Is this a gallon, do you think? In this
How much water? Yeah, how much water do you
gallon?
think is in these?
Half gallon? 2 gallons? 8 ounces? That's a pretty close guess.
Man, you were at Gary's class last year, weren't you? Actually, so what this is this represents roughly 1 cup
All right,
of
guys,
water in volume.
Thank you.
All right. And the whole idea, we could set these down. Guys,
Yep.
thanks guys so
Big
much
round
for
of applause
helping
for
us.
these guys. So
Yeah.
what those 3 pipes have in common, if I'm saying this right, is
Yep.
each one of these pipes holds 1 cup of water in this pipe. And isn't that crazy to think that this and this is the same water volume? But look how much further I can go if I'm using 1/2 inch pipe.
We could take it one step further, Matt. And
What
we
else
could
you got
take
for us?
1.25 inch pipe, and we could take 1 inch pipe, 1.25 inch, 1.5 inch. And if I dig deep enough in here, I could bet you I find one more piece of
I think
pipe.
there's one more in there. If
Well,
the bucket made it from Austin correctly.
If it didn't, doesn't matter. This is the same volume as well.
These are
All right.
also 1 cup of water.
So 1 inch pipe isn't uncommon to see in some water distribution systems, residential.
Yep.
A little bit larger scale of home might have some piping that is this large, even on the hot side.
Yep.
Okay. And why that makes a difference, or why that's significant, is we need to, once that water in the pipe is cooled down, like you were talking about, when
Yep.
you're waiting a couple minutes to get hot water at the sink, we need to replace that water with hot. And we are just wasting it, watching it go down the drain, that cooled down water. That water that was at that volume of water that we're waiting for, we've paid to heat one time at least.
Yep.
Probably multiple times, actually, through standby loss and things like that. But with these low flow fixtures, we also run ourselves into problems too, where it takes sometimes even longer because we don't have enough water flowing through the pipe in velocity or feet per second to displace that cooled down water with hot water. So
Yep.
further wasting more gallons of water.
You think about most homes in America, most of the pipe going through there is a 3/4 inch line. And 3/4 inch lines, when you've got a 5-gallon toilet, were really important, especially when we're thinking about delivery. But what's our fixture? What are some of the flows over the years from, let's say, a common shower head? Let's say, Eric, 25 years ago, if my wife turned the shower on in the 1970s on my house, what was the flow on that shower head roughly, do you think?
Between 4 and 5 gallons per minute.
And today we're at what?
The the typical shower head is roughly 2 gallons, 2.5. We see some low flow, high performance shower heads that are running a gallon or even less.
So if I plumbed my house with this 3/4 pipe and I was expecting to run 5 gallons down my shower, like a 1970s house that was built, I've got a lot of water in that pipe, and I'm worried about having enough volume and enough flow to make sure I don't have pressure drops. Now, what happens if I switch to this pipe and plumb my house with this? Now, if it's a 1970s house, it probably wasn't plumbed with a lot of 1/2 inch until you got to the twig, until we got to the end of the line. But most of the main lines were not plumbed with 1/2 inch for the reason that they were worried there wasn't enough volume. They were worried about pressure drop. In today's modern homes, new construction, we're still seeing plumbing plans, plumbing designs like we've always done them, and they end up with problems because we've got very low flow fixtures, but we also have typically very big pipes that need to evacuate a lot of water. Remember, these two pipes have the same 1 cup of water in them. So if I've got a lot of this pipe between my water heater and my very low flow fixture, we're talking about really long wait times. In our series that Eric and I filmed, we get into 3 kind of general types of plumbing plans. Should we actually, since we have a minute, why don't we actually give them the kind of overview on those real fast? There's really kind of 3 ways that we figure you could plumb your house. Will you explain kind of the basics behind a trunk and branch system, Eric?
Yeah, so a trunk and branch system of hot water or water distribution in any sort is probably what you're most used to. So you have a water source, let's say your well or your meter, and you come out of that with a main and you feed a water heater close by. And then from that point on with your cold water piping, you're going to go to your nearest fixtures. And that main is going to continue on because you probably have more than one sink in your house. So it's got to get to the next. But along the way, we drop off what we call a branch or a twig, right? So we've got the main line and we've got a branch line coming off of it. The main line is typically larger. 3/4 inch is very typical for a residential application, maybe 1 inch or larger, depending on the size of the house. We size that piping based off of the demand that we put on it. We're using charts out of our code book to do it.
Yeah.
So that would be a trunk and branch. So the main line with the branches coming off to feed individual fixtures or bathroom groups.
The next type of plumbing system that we see, and it's actually the one that I used in my house, is some type of loop system where we have a main branch that runs through a loop in the house, and then we have smaller twigs. And in fact, typically you might see that main branch being something like a 3/4 line, and it's funny that it's in a circle shape. But let's say I'm the house. It's running through the house in a circle. And then, Eric, what are we doing off of that to get water at each one of our fixtures?
Same thing again. We're using smaller pipes to feed water distribution to the fixture coming off the main again. And then the third type would be like a home run system or a manifold system. If you could consider a centralized location like the water heater or your mechanical closet, wherever the water is coming into the house, and running individual pipes, smaller diameter, typically 1/2 inch, as a home run from every single tap point to the manifold. And we manifold them all together. And then we have just one source of water distribution further away, smaller pipe feeding it.
How many of you, are, out of curiosity, are plumbing your houses with manifold systems? George did at your house in West Virginia?
Manifold system, okay.
We got one. Anybody
It's
else?
very popular with repipes and retrofit and
one?
remodel.
Yeah, it's also very DIY friendly.
It is.
Because it's really just one central location, almost like a circuit breaker type location board. And then you're running continuous, let's say 1/2 inch lines from that one central location to each individual fixture. And it's an appealing system in a lot of ways because I can shut off each individual line. So if I had a drippy faucet in my daughter's bedroom and I didn't have the time to fix that drippy faucet, I could go down into the basement and just click that off and it would turn off just that one section of plumbing. So there are some benefits to it.
Or if a pipe were to be damaged, let's say in a wall or something like that along the way, we could isolate that one pipe and from the rest of the system. So there's an advantage there. There's also disadvantages. A couple things is it uses more material. So on the cost side of things, it's going to cost a little, it's going to be higher cost by comparison. It's also going to take more labor.
Yeah.
Right.
That's right.
So if we're running individual pipes from every single fixture back to a central location, it takes more time to do that versus run one main and shorter pipes along the way.
Yeah, for sure.
Just kind of the logistics of it. I don't make it up. That's the way it goes.
Now back to the system that I plumbed my house with. I basically have, if any of you guys seen the videos of my house under construction, a couple of you did. I ran a 3/4 line in the ceiling that ran from my water heater on this side and basically hit all of my fixtures and then back to my water heater, if I can make a loop on this here. And then I took 1/2-inch twigs, or those branches. I never know if I gotta get my terminology right.
No, I like that you call it twigs, but I do call it branches. It's
Okay.
totally up to you. It
So
doesn't matter.
I
It's
took 1/2-inch
interchangeable.
branches, pardon me, from this main loop to each one of the fixtures. Now, this is not the size of the loop, obviously. This is basically, if you can kind of picture my whole first floor ceiling, this is where my loop is. The beauty of this system now is I have a circulation pump that's an on-demand circulation pump. There's a lot of different options. And in fact, Eric turned me on to a new one I never knew about until just recently. But the one that I've got has basically a taco pump at the water heater with an on-demand button at each one of my fixture locations. So when I get to, let's say when my kids get in the shower, they've got a low volt button on the wall that kicks on, and then this loop is pre-charged with hot water. So it's a 3/4 line, so there's a fair amount of hot water in there. Remember, this is 1 cup right here, and mine's probably, I don't know, 35 or 40 feet in a circle, something like that. So that's a lot of cups of hot water. But what it does then is this loop is pre-charged. So now all I got to do is get rid of that twig. And as long as my twig is this dimension or smaller, I've only got 1 cup of hot water in this twig to get rid of. So if there's a faucet at the end there that Eric turns on and this loop is charged with hot, I've only got to get the cold out of this pipe before it's hot coming out on that side.
Yeah, and so how that works, and we can time it out and we can do measurements ahead of time. Actually, all of this could be done on paper before it's installed, but we could prove very simply by using things like pressure and velocity in feet per second. In a typical plumbing system, we're moving water through the pipe at between 5 and 7 feet per second. That's what this is designed for. And if we have a specific distance of pipe that we need to run that branch or twig off the main, that circulated loop, we're going to start calculating things like 3, 4, 5 seconds before the water is hot at the fixture. And we can also then calculate volume because we have a fixed volume of the piping, right? We know what it is per foot. This 16-inch pipe, or 16-foot, is that what we were? 12-foot pipe
12 foot.
is roughly 1 cup of water, right? If I go 8 feet, 12 feet, that's pretty close to what you would have to go up the wall, over across to your nearby circulated main. Very small amount of water in a very short amount of time. My customers, being the guy that's called when things aren't going so great, don't call me when that's the situation because they're very happy. And I know each one of you brought it up, the hotel. You hit that water. I know each one of you are probably like, oh my gosh, it's hot already. At least that's the way I am. I'm the plumber. I'm paying attention to it.
I was too.
But it's significant, right?
Yep.
And so that's the benefit of the hot water recirculation.
Now, there's a bunch of options for circulation out there. There's even retrofit options if you're a remodeling contractor out there. I did that at my old house. I mentioned my 1970s house that I remodeled. It had 75 or maybe it was even more piped feet between the water heater on one end of the house. My furthest fixture away was actually my master shower area. So that was really far to get rid of all that cold water before the hot replaced it. What I did was I put an electrical outlet underneath the furthest vanity, and I put a pump in there so that when we walked into my master bedroom, I hit a low volt button. The pump circulated the water in that pipe all the way back to the water heater because I put a recirc line in. And now, even though it was really far, I just had to wait until the pump worked, and I just heard this little low hum underneath my furthest fixture. And within, I don't know, 10, 15 seconds, the pipe was pre-charged. So now when I turn that faucet on, I only had 2 or 3 seconds. So it is possible to retrofit these, and you can even do it with existing piping, right?
Yeah, so you don't actually even have to have the loop system or a dedicated return pipe back to the water heater. There's a lot of products on the market. Each one of them, each of the companies that are marketing and selling recirc pumps have this type of system. So we can put the pump either at the water heater or at a remote location. And we use this really cool little device called a crossover valve. And it's a little thermostatic valve that could be installed between the hot and the cold at that far away fixture. and that pump then will push water through from the hot side, drawing hot water out of the tank or your tankless or whatever your source is, and push it into the cold side. Sounds a little counterintuitive, but really what it matters is that we're maybe warming up the cold side a little bit. Probably doesn't matter in a bathroom sink.
Yeah.
But we're not wasting water waiting for it to get hot at the
Eric,
sink.
give us a couple of manufacturers or product names on some of those that you've used in the past, just so someone, if they have that situation, can look it up.
Yep. So there's a lot of them out there. One of the major ones would be Taco. They're made a U.S. manufacturer of Rhode Island. It's spelled Taco, T-A-C-O.
We're in Texas. It's a taco.
They make a pump system called the 006 E3. Either way, it's a pump made specifically for hot water recirculation. Pretty cool, super efficient ECM pump. Also, another big one, largest manufacturer, Grundfos. They kind of pioneered this whole type of system. They also use a crossover valve in this type of application. They make these pumps. These manufacturers also make pumps that can be applied to the more the dedicated return system without that crossover valve. But they've got both options.
The one I use at my house was a company called Metland. I don't think they're here, but they make a demand system that basically uses a taco pump that had the controls from Metland, and I've been real happy with that.
Yep.
Our video series is coming out, I think December period, the perfect plumbing plan. We're going to dive into each one of these. It's been co-hosted by a really well-known mechanical contractor by the name of, he's super well-known that I forgot Ross's name for a second. Ross Trethewey. His dad is Richard Trethewey. That you probably know that name. Some of the gray-haired men like me grew up watching his dad plumb on this old house for all those years.
Watched him.
You're great.
Oh, wait,
you have gray hairs.
Dang.
Yeah, you remember?
Dang.
Sorry to tell you. Don't worry, Heather still thinks you're attractive.
Do you want to touch on just the design aspect of the three different types and why that matters, like that hot water triangle? Do you want to go over that real quick?
Yeah, let's do it.
Okay. So in the series, we're not going to get into every technical detail, but Ross, I bring it up because you brought up Ross. Ross Trethewey is an engineer, and he was super kind in teaching us this, and I was fascinated by it. So we could do something that Gary Klein came up with, Ross is prescribed to as well, as we measure the hot water needs in your house under a system called the hot water triangle, right? The hot water triangle isn't a type of piping system or anything. It's just overhead look at your design, where your plumbing is laid out in your floor plan of your home. And it's measuring as a percentage ratio of square footage where your plumbing is versus the whole square footage of the space, right? So let's say you had 1,000 square foot floor plan, and you had plumbing in every single corner, and we, except for maybe a few feet, the garage or something like that, and we did that ratio. We compared how much square footage of plumbing there is versus the square footage of the house, and that's what we come up with, that ratio, that percentage of a hot water triangle. We want that number to be as low as possible. And your number was kind of high in your house.
It was
initially, right?
Yeah, it wasn't great, which meant that I needed that pump.
Yeah,
to help me get it there close. However, I did something really excellent at my house. That was because of Gary's recommendation.
Yeah.
And you know about where I'm going on this.
Yeah. So you decreased your hot water triangle.
Yep.
Right.
Yep.
So instead of having a single source loop system covering the entire floor plan of, let's say, this building, we then can consider, well, maybe we don't want bathrooms or sinks or everything located as far away from the water heater source as possible. We could bring them closer together, and that would lower that ratio, right? It would drop that rate, the number of the hot water rectangle versus the square footage. The number would get smaller. That's what we're trying to do. That's what you did. So talk about that.
Yeah, so I'm slab on grade construction. I built my house down in Austin. I didn't have a basement. One beautiful thing about basements is you can just move that water heater wherever it makes sense and make a mechanical closet where there's a bathroom right above you or maybe a kitchen sink right above you. At my house, I didn't have that luxury, and I just thought, oh, I'll put it in the garage where everyone else does, right? Maybe I'll put a heat pump water heater in, and I'll help space condition my garage. But when our friend Gary looked at the plan, he said, Matt, your master is right here, and your stairs are right next door to the master. Why don't you put the water heater under the stairs and just make a closet there? It was like, why didn't I think of that? That's so smart. So basically, my water heater is less than 6 piped feet from every fixture in my master bath. I turn my shower on, and I'm seconds for hot water. I turn my faucets and my 2 vanities on, I'm seconds because my water heater is right there. I don't need a circ loop. I don't need to press a button, nothing. It's literally right there. And it's funny, since I've done that, that was 3 or 4 years ago, I feel like I go into every client meeting these days and every architect meeting like, why is the water heater here? Especially on slab on grade houses. Again, if you have a basement, it can be easier. But I'm always thinking, let's move that mechanical room. And I ended up using some hinges from my friends at Sugatsuni and turning it into a cool feature. I made 2 hidden doors in a row, and I made a door that was full height in my 9-foot ceilings and paneled the wall. So now I just have a touch latch from Sugatsuni, and I walk right into my water heater closet. It's right smack in the middle of the room. It's a perfect location. It is a heat pump water heater, but it's a split heat pump. Will you explain what that means?
Yeah, I'm sad if you missed it. I'd love for you to watch the video when it comes out, but I just did a whole presentation on different water heater systems. A split system heat pump water heater is a storage tank, a passive storage tank, no heating elements or anything like that. Yours in particular, it's made out of stainless steel, which is a great benefit too for longevity. But that tank having no mechanical connections, electrical, anything like that, no fan, no venting, no gas. And no elements to heat. The water is heated outside in what looks just like a mini split heat pump, an outdoor unit. Looks identical to it. In fact, I challenge you to figure out anything out about it differently than that. But we're just running hot water or water piping, hot and cold between the 2 units to the outdoor unit. The water heater's outside. Really cool system.
That's really
Performance is amazing.
It's been amazing. I've loved it. As a side note, by the way, whether you're watching this on YouTube or if you're in the audience, I missed his presentation. I would have liked to have seen it. Everything you see at the Build Show live is being taped. So for our friends watching at home right now, you will be able to see this conference. It'll be up in about a month-ish. Hopefully I'm not making anybody have a heart attack on my team right now. But everything we've got, including this, all the stages, this is the Huber main stage, the Pella Build Better stage, and the Know Better stage, all those stages, plus all our classrooms. So if you didn't get a classroom education pass, those are being taped. Or, you know, like Matt Sneller that has 10 folks who maybe didn't make it from the team at home, he could go, hey, this is an awesome presentation. Let's watch this at our next project manager meeting together, right? We want to make sure this is a good time.
I think Don's getting upset that we said like a week or 2. He's
it's a little further than a month.
It's gonna be
at some point in the not too distant future, we will have the videos. Let's put it that way. Was that a vague enough to be perfect?
Yeah.
Alex is over there crying right now because I just.
Let's get back to your house and how you decrease that hot water triangle. Another way you can do that, if you consider design, and this is really what Gary Klein, our friend, would love for all of us to consider, is actually point of use hot water generation. All right. So consider something like a small tankless water heater that may not have a huge amp draw, doesn't have any venting, small in its own footprint, and could be put in, let's say, immediately at the need, like a
powder bath,
a half bath, a full bath for, the upstairs guest bath.
That's right.
Not having the need to run that hot water loop with recirculation to faraway points now is decreasing our hot water rectangle. Okay, because that's how we do that math. We've moved the source, like you did, closer to the demand or the tap, right? We could do that with individual water heaters throughout the home too.
The other thing I want to spend a minute talking on, it's one of my favorite topics, is let's talk about pipe systems for a minute, Eric.
I love it.
You and I brought several examples of cross-link polyethylene pipe, PEX, up here to talk about. And I plumbed my house with this as well. This happens to be SharkBite brand, but there are a bunch of manufacturers who make PEX pipe. There's a lot of benefits to plumbing a house with PEX. Why don't you give us just a couple of bullet points on that?
First and foremost, installation. It's easier and faster to install, which is going to decrease labor hours. It's faster to install because it's a flexible light product, and we can use less fittings, right? So you can see this spun around in 360 degrees with no additional fittings added to it. That directly affects its performance, the amount of time it takes to put it in. So we're lowering costs right there. It's also just easier to work with overall.
I want to show something that I was a big fan of when I plumbed my house. What do you call this, Eric? What's the technical term?
Technical term would be a bend support.
So what you're looking at here is basically a piece of plastic from HoldRite. There's probably some other brands as well. But let's say if I'm coming up a floor and I need to go out a wall to service a laboratory, instead of putting a 90-degree fitting on there, if we're using a flexible PEX, especially a PEX A, I can do this with PEX B too, though, right?
Yep, absolutely.
We can use a bend support, which will keep it at that perfect 90. And then the beauty is now I have one less turbulence spot as well. Every time I put a 90-degree fitting in, the water, as it makes that turn, the water tumbles and there's turbulence added to the line. I'll also have added one less spot that may not be a problem in the future because now I don't have a fitting there.
Yeah, so the fitting in a 90 would have 2 cuts in the pipe. They would be joined to the fitting. That would be potentially 2 leak paths. So having the bend support eliminates that. It's actually makes for a nicer, cleaner installation and keep pipes a little more orderly.
And some manufacturers like HoldRite have even come out with this product, which I made an Instagram video on when I saw it because I was literally a little bit giddy. I think you were too. This wasn't just me. You were absolutely.
I think they're fantastic. I think I was excited to show you, and your reaction was fabulous.
So talk me through what we're seeing here, Eric.
Yeah, so this is a company, HoldRite, owned by a company RWC. RWC owns companies like Cash Acme, which is a big plumbing brand, or SharkBite. This is called a fixture box, and this is part of a system that can be adapted to a lot of different installations, but it's made for a stub out of a fixture, like a lav faucet or anything that we're going to connect to, like, let's say, a quarter turn shutoff valve. What's really cool about this, you want to explain it just overall?
Yeah. Well, bend support's already pre-included.
Yep.
Also notice the pipes on there already. And the reason why is because this valve that's on the end, which will end up being my supply line for my toilet, let's say, my ball valve, my quarter turn ball valve, if I can get it to turn, come on now, don't embarrass me on YouTube, is already pre-attached. And check out that really cool orange you got in your hand there.
Yeah, so this is the mud guard. So we put that on the rough end to protect it. It's nice and bright, so it's probably going to be seen. And oh, you already grabbed it.
Oh, you have a different size.
That's all right.
Same one.
Sorry. So that mud guard's there to keep it protected during the installation. These are available in copper too, but this PEX ideal. You're just going to add one joint here, of course, but it's already assembled. There's a couple of different components. You've got some support brackets depending on how you're installing this. What's cool about this is a huge labor saver, and that's why I wanted to show you, because I think this is worth sharing to residential contractors. This was developed for the hospitality and the commercial market, like hospitals, large scale housing, stuff like that, hotels. But we've got that mud guard where we removed it. Now we're on the finish. So we're on the top out stage of the job, right? Installing fixtures. Pull that off, and then this escutcheon screws on just like that. That's really nice. Now, underneath the cabinet, that hole could have been, you can get different size escutcheons too, but that hole could have been just a little bit off. We can cover it up. Looks really nice.
That's right. I could use that for my lavatories too, right?
Yep. And this can
lab sink.
And you can also have this behind your toilet, so you can see just the valve sticking out. Very nice. Doesn't look like a piece of PEX sticking out of the wall, which some people don't like.
And the other thing that Eric told me that I didn't necessarily know intuitively is that this, what am I trying to say? This quarter turn stop is also replaceable on this unit, which I really like.
It's basically a compression valve. It's not exactly that, but it's readily available through the manufacturer, and it installs just like a compression valve, super easy.
Yeah. What other benefits of using PEX would you say versus, let's say, some other pipe systems when we're thinking about the perfect plumbing pan? Eric, anything else you want to mention?
Yeah, PEX it's proven to be a long-lasting material. It's quieter by comparison to other materials on the market, specifically copper. Although copper's great water distribution material for sure. Higher level of cost and labor to install. So your install cost up front on copper are going to be significantly higher than PEX. But PEX being a flexible material, easy to install and long lasting, we've more or less proven that in the industry over the last 30 plus years.
Give us your expert opinion on what should and shouldn't be insulated on the pipes in our house.
You should be insulating both hot and cold. especially cold if you live in an area with high humidity.
Mm-hmm.
But our code, the UPC code is what we work under in Minnesota, requires us to have a wall thickness of insulation that is equal to the size or diameter of the pipe. So this being a 3/4 inch pipe, should not have a piece of 1/2 inch wall insulation on it, but we should be insulating all of the piping, especially hot. At minimum, our code requires us to insulate the hot piping now, but that's to contain the energy and to lengthen the time of that standby loss.
Right.
Right? Does that make sense?
I insulated both hot and cold at my house, and I got to say it's been really excellent at my house because even though I have quick hot water delivery, if I jump in the, let's say I wash my hands, I jump in the shower, I come back to that lavatory to shave 5 or 10 minutes later, that water is still hot because I insulated those pipes. And I would tell you that you said it really, really quickly. We should insulate our cold side as well to prevent
condensation.
Right. But I think we forget that as builders. There's a huge benefit to insulating not only your hot side, but your cold side as well. And in Texas, we tend to have very warm inlet temperatures. I think where I am in Austin, Texas, my average inlet temperature is probably almost 60 degrees, meaning the cold water coming in from the street's pretty dang warm. What is it where you are in Twin Cities, Minnesota?
36 degrees. So quite a bit difference. And in a humid environment, you're going to immediately have condensation no matter the piping material. Yeah. If it's not insulated and insulated properly, that's one thing we should bring up. There's a lot of different insulation materials. Typically, you'll see plumbing contractors installing like this foam rubber type of insulation with an adhesive joint on it. Mm-hmm. You can buy these without the adhesive joint as well, so you have continuous wrap around there without any gaps. But if there is air gaps in the installation, let's say you miss a little bit of pipe, or when you're going around 90s or things like different fittings, T's and stuff like that, those need to be addressed because you'll have condensation build up on those open spots as well. Even just gaps in your insulation can cause problems. The reason why it's a problem is because if you think about piping that's over a finished ceiling, behind finished surfaces, stuff like that, that condensation can be significant enough to where it could pool and cause water damage on your finished surfaces.
Yeah, I think you said it, but I might have zoned out. What wall thickness do we want on our insulation for our pipes?
Yeah, so my code says that I have to have equal thickness of wall to the diameter of the pipe. So if it's a 3/4 inch pipe, I have to have a 3/4 inch wall insulation. And that's based off of the surface area. That's they're worried about the volume of pipe and how much surface area is exposed to the atmosphere. That's why they're doing that. Worried about the thickness or the R value of the installation.
Gotcha. Oh, I got another master plumber question that I couldn't figure out for a long time until Eric explained it to me. If you see Gary's talk on hot water that I've seen a couple times, we love this guy. We talk about him like he's our hero because he is. He talks about 3/8 PEX. This is a 3/8 PEX product. And if you think about how little water is in here, we could go a long ways with this and still deliver hot water very, very quickly. But this is not used very often. Why is that, Eric?
Yeah, so we haven't talked about it yet. We talk about it in the series. Our codes have what's called a hot water piping sizing chart. It's a Hunter curve is what that was, and it was developed in the 30s and 40s of the 1900s. So anybody here born in the 1900s? Most of us, yeah. These sizing charts were taken into consideration that at the time we had water pressures of between like 20 to 30 to 40 psi at the high end, and we had very large pipes to accommodate that very low pressure, and we had fixtures that ran significantly more water through them, and so that all of the sizing based off of that old archaic plumbing systems that we've long since forgotten don't serve us very well now, and say that we can't put piping behind walls or inaccessible or beyond certain lengths of physical pipe smaller than 1/2 inch.
Yeah, so ultimately it's a code issue.
It's a code issue. Ultimately, there are some considerations. We can't just go start downsizing our pipes either. We have to know things like velocity, pressure, and distance in order to size properly. But the IRC, is that what the other
International Residential Code?
Yeah, so the IRC says that you can use 3/8 in some applications. The UPC doesn't yet.
Yeah, maybe that'll change at some point. Eric, we've got about 5 minutes left. We're going to take some Q&A if you've got some. But before we get there, I want to ask you one more master plumber question that I bet a bunch of my nerdy builder friends are wondering. Talk to me about the difference. If we didn't spend a ton of time on it, but we said we generally do like PEX as a plumbing system. It's probably one of the most popular, if not the most popular in all the U.S. Talk to me about the difference between an expansion fitting and a crimp fitting on PEX. What do you like about them? I don't think we have any in here, do we?
Yeah, I don't know if we have any, and also it'd be hard to see from here, but there are multiple types of PEX fittings, like you said. Really, the two main types of fittings that we concern ourselves with is an insert fitting and an expansion fitting, and they require they're used in basically two different types of PEX. A PEX A is a pipe that we call it PEX A because of how it's extruded out of the machines that make it. It's not like a grading system, but that PEX A fitting, we use a specialized tool. We expand the
Interior,
the inside diameter of the tubing, because the fitting itself, the barbed end that goes in the tubing that you probably can see in your mind's eye there, is actually the same diameter as the ID of the tubing to start with. So they don't connect, right? It'd just be like taking, give me that piece of 3/4 just for effect.
Yep.
It'd be like taking this, the fitting, and this, the end of the pipe, and trying to put them together. That doesn't happen, right? So we use a tool and we expand this out, and then the fitting will fit inside of it. What that'll do in theory is allow better flow characteristics through that piping, less of a pressure drop. That's just one type of fitting. It's also, there's an advantage maybe. You can't dry fit that kind of connection. You have to go through the whole process, which is significant to my plumber friends who have had water leaks or maybe catastrophes like me and
from a dry fit.
Yeah, seen whole ceilings cave in on, model homes. But anyway, the insert fitting is much the same. It just uses a different joining process. We don't have to expand the pipe. The fitting itself is now smaller in diameter and can go directly into the pipe. And then we have some type of fastening system on the outside of it. That's where we see a few different ones. The most common is a small ring that kind of looks like a wedding band. It's made out of copper, and you use a tool to literally clamp it 360 degrees around it.
With a fair amount of pressure, right?
Yeah, there's a lot of pressure involved. You can use a hand tool to do it, or you can use a power, like a press type tool.
Yeah,
those are the most common.
And if you use the hand tool, it takes a bit of force. This isn't just a quick boop.
Yeah, and
It takes a second.
So I'm gonna date myself, but when I started installing PEX in, let's say, 98, 99, we were installing the PEX A system made by Uponor. That's the brand, and most people will be familiar with. Their system, you install a ring on the outside of the pipe. It looks like it's a plastic ring. It's made out of the same type of material the PEX is, but it's large enough to install on the outside. And then we used a hand-operated expansion tool.
Did you really?
Yeah, and this is how wild it was. Because you don't have three hands, you use this belt that you put around your waist that held the tool. It kind of gave you a way to hold the long handle of this tool.
It's a family show, Eric.
Yeah, I know. And then you just kind of give it like one of these things, and you're doing that a little bit as I'm live on YouTube, and to expand this pipe. And at the same time, you also had to like spin the pipe around and stuff because you had to rotate the head of that tool a little bit. It was
a dance.
It was a dog and pony show for sure. And
I mean, you and Heather have been married 30 years now, so it's.
But it was physically awkward and cumbersome in the installation. You can imagine trying to do that in the ceiling
overhead
of in a basement, right? Or on top of a ladder. Since then, we've moved to power tools that do it automatically. The head rotates automatically. There's all the skill has been taken out of it, which is great if you ask me.
I have a buddy who's a plumber in my town that runs a shop that does like 3,000 homes a year. Like they're a giant shop. His grandfather started the company. And about 5 years ago, he moved to expansion for that reason, that you can't dry fit it.
Yeah.
And he just was looking for that, especially with the volume that he does. I've never had a problem with a crimp fitting in my short lifetime, but I don't do 3,000 houses.
Right.
And so the chances of a failure happening when you have a crimp are pretty low. Like I've literally done.
Yeah, these are reliable systems, but I have made the mistake. I don't do 3,000 houses, but I do a fair amount of piping connections throughout the year.
Yep.
And I did have a mistake, and I saw the sheetrock of a newly finished parade home, the basement sheetrock sitting on the basement floor because a fitting was dry fitted. I didn't put it together properly.
Man,
It was entirely my fault. It wasn't a material problem.
That's terrible.
So that actually, so then is when I switched to expansion
Thanks,
X at the time.
Yeah. Guys, we got a whole lot more to talk about on this topic, and I love Eric's videos because I've always said I would have liked to have been an apprentice plumber. Maybe I'll do that as my second career and come out and apprentice with Eric out there in the Twin Cities. But if you want to see more of Eric's work, you can see a ton of videos. He's been with us for probably 3-4 years now on the Build Show, buildshownetwork.com for any of those watching on the YouTubes. And look out for our series, The Perfect Plumbing Plan. That is a mouthful of peas to say.
Yeah.
Coming in a not too distant future. If you're here live in Dallas, the show ends in 15 minutes, but I think we're about to do a toast. And I suspect I'm seeing a bunch of, some of you already have it. There's some toast glasses. If you guys want to come, I'm going to give a toast here in a few minutes. And if you're live here in Dallas too, don't forget about our tailgate. When the show ends at 5 o'clock, we're literally like, is it Elizabeth? Is these doors right here? We're literally going straight out these doors to a tailgate for the next 3 hours, 4 hours until 2 a.m. is what I've been told. Something like that. So get your ticket if you don't have one. It's pretty inexpensive. We've got beer out there. We've got food out there. We got some fun games.
Oh, wait, no.